Hi there, and welcome to another video for the Edexcel Further Pure 1 Maths A-Level syllabus. In this video we do the past paper questions on numerical methods. Let's get going straight away. First question's about the Newton-Raphson procedure. Right, let's get going. It gives us a polynomial f of x and it says use differentiation to find f dashed x. You will remember for any polynomial, say a polynomial is of the form a x to the power of n, a is a number like 2 or 6, x to the power of some number, then f dashed x is n a x to the n minus 1. Okay, so using this here, f dashed x, bring down the power, 3x squared, subtract 6x plus 5. Nice and straightforward. Part B. It tells us that f of x is 0 has a root between 1.4 and 1.5. Starting off with an approximation for the root is 1.4. Do the Newton-Raphson procedure once to obtain an approximation for alpha to 3dp. In our formula booklet, it tells us the Newton-Raphson iteration. It is x subscript n plus 1 is equal to x to the n subtract f of xn over f dashed xn. Now we are told to take our first approximation x0 as 1.4 and we're asked to work out x1. Well, x1 therefore simply is 1.4 subtract f of 1.4 divided by f dashed of 1.4. So this is equal to 1.4 subtract, well, our original function was x cubed subtract 3x squared plus 5x minus 4, so it would be 1.4 cubed subtract 1.4 squared plus 5 times 1.4 subtract 4, all divided by, well, 3x squared, so 1.4 squared, subtract 6 times 1.4 plus 5. So all you have to do is tap that in your calculator and get the appropriate answer. So 1.4 subtract, and if you know how to use your calculator appropriately here, this is an easy task for you. And I get for my answer for that 1.455. So I get for that, rounding appropriately, I get x1 is equal to 1.455 to 3 decimal places. And we're done. We've got ourselves 6 easy marks. Next question. We're basically doing a Newton-Raphson. So the first part, we want to show there's a root between 1 and 2. All we need to do is work out f of 1, work out f of 2, show there's a change of sign, and then state because f is continuous and there's a change of sign, there must be a root. Using your calculator, type in x cubed plus 8x subtract 19, use the calc function and substitute 1 in. F of 1 would therefore be negative 10. Substitute 2 in and you would get 5. Then you state, therefore, change of sign, and f is continuous, therefore root between 1 and 2. Simple as that. Next part, we want to apply the Newton-Raphson procedure starting with x is 2 twice and give your answer to 3 decimal places. Okay, first things first, let's state our f of x. Our f of x is x cubed plus 8x subtract 19. It's always important to show your f dashed x before you start substituting into a formula. That would be 3x squared plus 8. Newton-Raphson tells us that x to the n plus 1 is x to the n subtract f of x to the n over f dashed x to the n, and now we're ready to substitute into our formula. Now x0, our first guess at this is going to be equal to 2. Now what I want you to do on your calculator, use your calculator efficiently, press 2 equals on your calculator. That will store 2 as the answer. And then instead of typing this in each time, what we're going to type in, we're going to say that in general, x, the n plus 1 then, is going to be ans, the previous answer you got, and we're substituting ans for x, the n here, subtract f of ans, which would be ans cubed plus 8 ans, subtract 19, all divided by f dashed of ans, which would be 3 ans squared plus 8. So we're going to do that. We're going to first of all type 2 equals, that stores it as ans. Then we're going to type ans, subtract, and then the fraction function, ans cubed plus 8 ans with brackets, subtract 19, over 3 ans squared plus 8. And then the beauty of doing it this way is if we press equals, we get ourselves 1.75 as our x1 then. x1 is 1.75. And then the beauty, just by pressing equals again, it works it out for us. So x2 would be 1.729. Remember, we're going to 3 decimal places, and therefore we're done. So that's the benefit of doing this way, especially if it asks you to work at x1 to x6 or something. This is a great method. Okay, part C, by considering the change in sign of f of x over an appropriate interval, show that your answer is accurate to 3 decimal places. Well, our answer is alpha is 1.729. And we're saying that's accurate to 3 decimal places. What we want to do is we want to show a change of sign in the upper bound, between the upper bound of this number to 3dp and the lower bound. If there is a change of sign, this number here to 3 decimal places is the answer. So we're going to add on 0.0005 and we're going to subtract 0.0005 and we're going to get here as the upper bound 1.7295 and the lower bound we're going to get 1.7285. We always do this. If it was 2dp, we would add on 0.005 and subtract 0.005. Okay. Then what we're going to do is we're going to work out f of 1.7285. We're going to work out f of 1.7295. Hopefully there's a change of sign, and that would mean this is accurate and the root to 3 decimal places. So in your calculator, type the function x cubed again, plus 8x, subtract 19, calculate and tell it you want to sub in 1.7285, and you're going to get yourself negative 7.7 times 10 to the minus 3, and if you substitute in 1.7295, you're going to get yourself 9.2 times 10 to the 3, and you can state change of sign, f continuous, therefore alpha is correct root to 3dp. Okay, because that number and that number to 3dp using upper bounds round to this, so that must be the right answer. Right, next question. Again, another Newton-Raphson, so let's proceed. Part A. Show f of x has a root in the interval 1.1 to 1.2. All you've got to do, as usual, work out f of 1.1, work out f of 1.2, show there's a change of sign, state f is continuous, and then you're done. So in your calculator, use the x capacity, type 3 root x, okay, plus 18 over root x, subtract 20, okay, and substitute in, press calc, and you want to put in 1.1, and you get yourself, when you do that, 0.309, and substitute in 1.2. With a bit of luck you get a negative number, and you do indeed, you get negative 0.282. And then you state that there's a change of sign. You state f is continuous, always must do this, and then you state therefore root between 1.1 and 1.2, and hey presto, you're done. Okay, next part, find f dashed x. Well, f of x is, let's write f of x out on this page. F of x is 3 root x plus 18 over root x, subtract 20. Okay, before you differentiate, you have to convert to index notation. So f of x, converting to powers, would be 3x to the half plus 18x to the negative a half, subtract 20. And then you could go ahead and work out f dashed x. Okay, bring down the half, so it would be 3, it would be half times 3x to the half minus 1. Then it would be plus minus a half, 18x to the minus a half minus 1, and you differentiate negative 20, you get nothing. So therefore, tidying this up, f dashed x, a half times 3 is 3 over 2, x to the minus a half, and negative a half times 18 is negative 9, or subtract 9, x to the minus 3 over 2. And you have your f dashed x then. And part C, using x0 as 1.1 as a first approximation, apply the Newton-Raphson procedure once to find f of x to 3 significant figures. Remember, Newton-Raphson says xn plus 1 is equal to xn subtract f of xn over f dashed xn. We're only doing it once here. Now our x0 is 1.1, so therefore x1 would be 1.1 subtract f of 1.1 over f dashed of 1.1. Okay, which would be 1.1. Our f again is this function here, so we just have to be careful when we're typing this in here. This would be 3x to the half, so let's just write our functions down again. F of x is 3 root x plus 18 over root x, subtract 20, and we said that our f dashed x is going to be 3 over 2 x to the negative half, subtract 9x to the negative 3 over 2. Okay, so when we're subbing this in, we're subbing 1.1 in here, and we're subbing 1.1 in here over this. So it would be 3 1.1 to the half plus 18 1.1 to the negative a half, subtract 20, all divided by 3 over 2 1.1 to the negative a half, subtract 9 1.1 to the negative 3 over 2. So it's a bit clumsy to type in the calculator, but it's just a process like that. So type that in the calculator, 1.1 subtract, use the fraction facility, 3 1.1 to the power of 0.5 plus 18 1.1 to the power of negative 0.5, subtract 20, all over 1.5 times 1.1 to the power 1.1 to the power of negative a half, subtract 9 1.1 to the power of negative 1.5. Press equals on your calculator. It's quite a big calculation here, but with a bit of luck you got 1.15 to 3SF. I got 1.15 to 3 significant figures, and that's my x1, and there are your 9 marks. Next question. Okay, this says the equation f of x has a root alpha in the interval 4 to 5. By using the endpoints of this interval by linear interpolation, find an approximation to alpha. First things first, I want to work out f of 4 and I want to work out f of 5 to show how big they are. So f of 4, if you sub in there, 2 to the power of 4, subtract 6 times 4, you get negative 8. And then 2 to the power of 5, subtract 6 times 5, you get 2. So let's draw a rough picture out for this so we've got something to work with. Okay, when x is 4 about here, you get negative 8. So you've got 4, negative 8. And when x is 5, you get 2. So when x is 5, you get something like 2 here. Okay, now the curve, we don't know what the curve looks like. The curve could be anything here. But for our purposes, let's just imagine it being a straight line. And let's imagine this point here, alpha, being an approximation to our root. And we're going to use linear interpolation to try and solve this. Okay, so I'm going to take away this here, because this just is complicating the situation. I'm going to group these. In future, you can just draw this straight like that once you've got a change in sign. Okay, so, but we do know we're looking for our root there. Our root is alpha, this point here. Okay, so we're going to use similar triangles. Okay, that's our point alpha, and we're going to say, we're going to consider these similar triangles here, and we're going to say the height of this one divided by the height of this one. So the height of this one is 2, so we're going to say 2 divided by the height of this one, which is 8. Because the triangles are similar, must be the width of this one, which must be 5 subtract alpha, divided by the width of this one, which must be alpha subtract 4. And all we're going to do is we're going to solve this equation for alpha. So this here, let's just simplify this before we go ahead. A quarter is 5 subtract alpha over alpha subtract 4. Now times both sides by this 4 and times both sides by the alpha minus 4. So I would get alpha subtract 4 is equal to 4 times this, which would be 20 subtract 4 alpha. Add 4 alpha to both sides and add 4. So 5 alpha would be 24, and then alpha therefore would be 24 divided by 5. And we would get ourselves about 4.8 as our approximation. So 4.8 as a decent approximation by linear interpolation. So nice, easy 3 marks there. Next question. It's a 10-mark question. Let's do part A first. Given that alpha is the only real root of the equation, show it's between that and that. Firstly, I would define f of x to be x cubed subtract x squared subtract 6. It's nice to have it in function notation. And we're going to work out f of 2.2, this endpoint, and we're going to work out f of 2.3, this other endpoint. Show there's a change of sign. As the function is continuous, there therefore is a root between the two. So in your calculator, type x cubed subtract x squared subtract 6, and the calculate button, work it out at 2.2. Hopefully with a bit of luck you get yourself negative 0.192, and then calculate at 2.3 and you get yourself 0.877, and then you state therefore change of sign, f continuous, and then you say therefore root between 2.2 and 2.3. Done. Easiest 2 marks on the paper. Okay, part B. Taking 2.2 as the first approximation, use the Newton-Raphson procedure once to f of x to obtain a second approximation. State your f of x is x cubed subtract x squared subtract 6, just as it was on the previous page. Get a mark for differentiating. Show the differential which you're going to use in the Newton-Raphson formula. 3x squared subtract 2x. And then Newton-Raphson says x to the n plus 1 equals x to the n subtract f of x to the n over f dashed x to the n. So translating this in terms of the functions, it would be x to the n subtract f of x, which would be x to the n cubed subtract xn squared subtract 6, all divided by 3x to the n squared subtract 2x to the n. Okay, so all we've got to do is start with x0 is 2.2 and x1 will be what I get when I sub in 2.2 in here. So it's just a calculator exercise here. So all you've got to do, 2.2 subtract, use the fraction facility, 2.2 cubed subtract 2.2 squared subtract 6 divided by 3 times 2.2 squared subtract 2 times 2.2. Tap that in your calculator and you should get yourself the answer 2.219 to 3 decimal places. Okay, and really there's a very straightforward 5 marks there. Next part, use linear interpolation once to find another approximation to alpha. So luckily in part A we worked out f of 2.2 and f of 2.3. I'm fairly sure going back to part A we did indeed. It was negative 0.192 and 0.877. So this is negative 0.192 and 0.877. 0.877. So let's draw ourselves our picture. When x is 2.2, we get negative 0.192, and when x is 2.3, we get 0.877. That point to that point. Therefore, there's a root between the two, and the root is here. Let's say we'll call it alpha, and then we just use similar triangles. So we say the height of this one, which is 0.877, divided by the height of this one, which is 0.192, must equal the width of this one, which is 2.3 subtract alpha, over the width of this one, which is alpha subtract 2.2. Okay, let's do 0.877 divided by 0.192, see if that simplifies in any way. Not particularly. So what we're going to do is we're going to times both sides by this and times both sides by this. So you would get 0.877 alpha minus 2.2 is equal to 0.192 2.3 subtract alpha. Times this out, 0.877 alpha subtract 1.9294 is equal to 0.4416 subtract 0.192 alpha. Add this to both sides, you get 0.877 plus 0.192. You would get yourself 1.069 alpha would therefore be equal to 0.4416 plus 1.9244. You would get yourself 2.366. So therefore alpha is 2.366 divided by 1.069, and you would get yourself 2.213 to 3 decimal places. So 2.213 approximately. Okay, so going back to the other one, 2.219 I got for the other one, and 2.213 I got for that one. Okay, next question. Okay, part A, show that f of x has a root alpha between 1.4 and 1.5. Same old stuff here, work out f of 1.4, work out f of 1.5, show that there is a change in sign. So, on your calculator, type x cubed, subtract 7 over x plus 2, calculate, and you want to calculate at 1.4. So you get yourself negative 0.256, calculate at 1.5, and you get yourself 17 over 24, which is 0.7083 recurring. Okay, therefore change of sign, f continuous, therefore root between 1.4 and 1.5. Again, as always, the easiest 2 marks on the paper. Next, starting with the interval 1.4 to 1.5, use the interval bisection twice to find an interval of width 0.025 that contains alpha. So what we're going to do, we know that f of 1.4 we're saying is negative 0.256, and we know that f of 1.5 is equal to 17 over 24, which we're saying is an approximate fraction is about 0.7083 recurring. Okay, let's draw a picture of it. So when x is 1.4, you have negative 0.256, and when x is 1.5, you have 0.7083 recurring. Okay, let's just draw a, here's our axes here. And we know the curve is, I don't know, the curve looks something like that. We know there is some sort of root here. Okay? So, we want to apply the interval bisection method twice. We're going to draw a table. So what we're going to do, let's just shrink this here. We'll make this shrinkable so we know what where we're going for here. So what we're going to do, remember the table we draw. The first thing we do is we state our A and we work out our f of A. Then we state our B and work out our f of B. Then we add them up, we work out A plus B over 2, and we work out f of A plus B over 2. Okay, and then we're going to decide which new interval to use, etc. So A was 1.4, f of A was negative 0.256, B was 1.5, f of B was 0.708, and A plus B over 2. So 1.4 plus 1.5 divided by 2 is obviously 1.45. 1.45. Now we want to work out f of 1.45. Now our f, x cubed subtract 7 over x plus 2. X cubed subtract 7 over x plus 2. So have that on your calculator. X cubed subtract 7 over x plus 2. Calc, and you want to calculate a 1.45, so you get yourself 0.221, etc. Now we're always going to take this end method. That's positive, so we want to take the negative that went with it. So our new A is going to be 1.4. It was the same before. But our new B is now going to be equal to 1.45. Okay? And we said that f of B is 0.221. Now we're going to work out A plus B over 2, 1.4 plus 1.45 over 2. 1.4 plus 1.45 divided by 2 is 1.425. And we want to work out f of that. So we want to do 1.425 cubed, subtract 7 over 1.425 plus 2. And we work that out and we get ourselves negative 0.0186. And we want to take that one, the new one, and that's a negative, so going with it, we want to take what made it positive, i.e. that one. So the interval, therefore, that we're finding in this part, the interval is therefore between these two numbers here. So the interval is between 1.425 and 1.45. And there are our 3 marks. It doesn't ask us for the actual root. It says find an interval of that width, and we've got that width, and alpha is certainly somewhere in there. Okay, part C, taking 1.45 as the first approximation to alpha, apply the Newton-Raphson procedure once to that, give your answer to 3dp. So f of x, writing in index form, is x cubed, subtract 7x to the minus 1 plus 2. Get your mark for differentiating. F dash x is 3x cubed plus 7x to the minus 2. Newton-Raphson, get another mark for stating it. Xn plus 1 is x to the n, subtract f of x to the n over f dash x to the n. If our x0 is 1.45, then our x1 will be 1.45, subtract f of 1.45, which is 1.45 cubed, subtract 7 over 1.45 plus 2, all divided by 3, 1.45 squared plus 7 over 1.45 squared. So it's just a calculate again, tap that in your calculator, 1.45 subtract fraction 1.45 cubed, subtract 7 over 1.45 plus 2, and then 3 1.45 squared plus 7 over 1.45 squared. And a bit of luck, tapping that in your calculator, you get the answer 1.426 to 3 decimal places, and you're done. Next question. Okay, let's just take a picture of this function because we're going to need it in each of the parts. So I'm going to use that throughout. So for part A, write down to 3 decimal places the value of f of 1.3 and f of 1.4. This is just a substitution game, so I will type in your calculator 3x squared, subtract 11 over x squared, press the calculate button, 1.3, you're getting yourself negative 0.14 4 to 3 decimal places. Sorry, it's my mistake there, sorry. If you to 3 decimal places is negative 1.439, and then you type 1.4 and you're getting yourself at 0.268. So you get yourself 0.268. Easy 1 mark. Next question. Let's just have the function there. The equation has a root between 1.3 and 1.4. Starting with this interval, use the interval bisection method to find an interval with 0.025 which contains alpha. Let's draw our table. We have A, f of A, B, f of B, A plus B over 2, and then f of A plus B over 2. Right, our A was 1.3 and our B was 1.4. We've worked out f of A and f of B is negative 0.1439, negative 1.439, and B was 0.268, 0.268. A plus B over 2 would clearly be 1.35, that plus that divided by 2, and we want to work out f of 1.35. so 1.35, and you get yourself negative 0.568. Now you always want the n column, so we want that negative, and therefore for a change of sign, for a root between them, we also want that one that was positive. So therefore our next A must be 1.35, and we get negative 0.568. Our B must still be 1.4, which is 0.268. Halfway between these is 1.375. If we work out f of 1.375, we get ourselves negative calculate here 1.375. We get ourselves negative 0.146. We always want that new one there, so we want that negative. We must also take that positive, so therefore there is a root between 1.375 and 1.4. So alpha is therefore between these numbers. Why? Because there's a change of sign between 1.375, which is negative, and 1.4, which is positive. And part C, by taking 1.4 as the first approximation to alpha, apply the Newton-Raphson procedure once. Now our f of x, let's just write it down again, 3x squared, subtract 11 over x squared, write it in index form so we can differentiate. 3x squared, subtract 11x to the power of minus 2. Get your mark for differentiating. F dash x is therefore 6x plus 22x to the minus 3. Okay, bring down the negative 2 and then reduce the power by 1. State your Newton-Raphson. X to the n plus 1 is equal to x to the n, subtract fx to the n over f dashed x to the n. Okay, our x0 they want us to have as 1.4. So therefore, you should be going down the page, but I'll go across it. x1, you want to only apply it once to get your answer to 3dp. x1 is therefore 1.4, subtract f of 1.4 over f dashed of 1.4. Now, it's just a calculator game to substitute 1.4 in here on the top and 1 here in the bottom. So let's see if we can do it all in one go. 1.4, subtract f of 1.4, which would be 3 times 1.4 squared, subtract 11 over 1.4 squared, and then over f dash x would be 6 times 1.4 plus 22 over 1.4 cubed. You tap that in your calculator, and x1 to 3 decimal places would be 1.384. And you're done. There's your 5 marks. And then that's it for this video. We have done every question on numerical methods. Thank you for watching.